The engine coughed once, twice, then died with a shuddering finality that echoed through the frozen Belgian forest. Technical Sergeant James Bates of the 3rd Armoured Division stood motionless beside the massive tank, his breath forming white clouds in the December air of 1944. Before him sat what German propaganda had called invincible, the Panzerkampfwagen Tiger Ausführung B, known to the Americans simply as the King Tiger. 70 tons of sloped armor and an 88mm gun that could punch through any Allied tank at 2,000 yards. The most powerful tank in the world, and it had broken down after traveling less than 3 miles. Bates had spent 2 years fighting German armor across France and into Belgium. He had seen Shermans burn, watched crews bail out of disabled tanks, attended funerals for friends who never made it out. The Tiger tanks, both the original and this newer, heavier King variant, had haunted American tankers' nightmares since North Africa. Every tactical briefing emphasized their superiority. Every after-action report documented their devastating effectiveness. Every intelligence bulletin warned of their invulnerability. Yet here one sat, immobile, captured without a shot fired, its sophisticated engineering betrayed by something as mundane as a failed transmission. The irony would have been amusing if it weren't so profound. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The story of how American forces captured intact King Tigers and what those captures revealed about German tank doctrine, engineering, philosophy, and the fatal gap between technological ambition and industrial reality begins not in the winter forests of Belgium, but in the drawing rooms of German tank designers 3 years earlier. In 1941, as German panzers swept across the Soviet Union, German engineers encountered a problem they had not anticipated. The 34. This Soviet medium tank possessed sloped armor that deflected German anti-tank rounds, a powerful 76mm gun, and wide tracks that allowed it to traverse mud and snow where German tanks foundered. For the first time, German tankers faced an opponent they could not reliably defeat. The German response was characteristically ambitious. Design tanks so heavily armored and so powerfully armed that they would restore German superiority through sheer technological dominance. This philosophy produced the Tiger I in 1942, a 54-ton behemoth with frontal armor up to 100mm thick. But even as the Tiger I entered production, designers at Henschel were already planning its successor. The requirement specifications for what would become the King Tiger were extraordinary. The new tank would feature sloped armor like the 34 but thicker 150mm on the frontal hull, 180mm on the turret front. The main gun would be the long-barreled 88mm KBUK-43, capable of penetrating 132mm of armor at 2,000 meters. The tank would be virtually immune to any Allied tank gun, while being able to destroy Allied tanks at ranges where they could not effectively return fire. On paper, it was magnificent. In practice, it was a maintenance nightmare waiting to happen. The King Tiger weighed nearly 70 tons more than any tank the Germans had previously produced. This weight strained every mechanical component. The Maybach HL-230 engine, producing 690 horsepower, was the same engine used in the lighter Tiger I. This meant the King Tiger was underpowered relative to its mass, with a power-to-weight ratio of less than 10 horsepower per ton compared to the Sherman's 11.6, but the real Achilles heel was the transmission. The Maybach Olvar transmission system had to transfer nearly 700 horsepower through a series of gears to move 70 tons of steel. German engineers had developed this transmission for lighter tanks and had simply scaled it up. The result was predictable to anyone familiar with mechanical engineering. The transmission operated at the absolute limit of its design specifications. Any additional stress, mud, steep inclines, rapid maneuvering would cause premature failure. German tankers knew this. Maintenance crews knew this. Even some commanders knew this. But the strategic situation of the Third Reich in 1944 did not permit acknowledgement of such limitations. Germany needed wonder weapons, not honest engineering assessments. The first King Tigers entered combat in May of 1944 with the 503rd Heavy Tank Battalion during the Allied breakout from Normandy. Initial combat reports seemed to confirm their superiority. A single King Tiger could engage Allied tanks at ranges where return fire was ineffective. The psychological effect on Allied tank crews was significant. Encountering a King Tiger meant either withdrawing or attempting a dangerous flanking maneuver. But those same reports also contained troubling details that German propaganda chose to ignore. Of the 4 King Tigers deployed in combat near Villers-Bocage on June 13, 1944, 2 were lost, not to enemy action but to mechanical failure. One threw a track during maneuver. Another suffered complete transmission failure after traveling less than 15 miles from its staging area. The pattern repeated throughout the summer and fall of 1944. King Tigers would deploy to the front, achieve tactical successes through superior firepower and armor, then break down at rates that horrified their commanders. The 501st Heavy Tank Battalion, equipped with King Tigers, reported that mechanical reliability was so poor that they could rarely field more than half their authorized strength. Crew training manuals for the King Tiger included detailed instructions on field repairs for transmission problems, a tacit admission that such failures were routine. Maintenance crews were instructed to carry spare transmission components, but by late 1944, German logistics were collapsing. Spare parts were unavailable. Tanks that broke down were often abandoned because they could not be repaired in the field. American intelligence officers knew German heavy tanks were mechanically unreliable. Interrogations of captured German tankers had provided that information, but the extent of the problem remained unclear. The Germans destroyed most disabled tanks to prevent capture. What American tankers needed was an intact vehicle they could examine in detail. They got their chance in December of 1944, during the Battle of the Bulge. The German offensive through the Ardennes, Hitler's last major gamble in the West, involved significant numbers of heavy tanks, including King Tigers from the 501st SS Heavy Tank Battalion. The plan required these tanks to advance rapidly through narrow forest roads, cross rivers on bridges that might not support their weight, and maintain momentum for days without major maintenance. It was a plan that ignored mechanical reality in favor of operational optimism. On December 16, 1944, the offensive began. German tanks poured through weak points in the American lines, achieving tactical surprise and creating chaos in the Allied rear areas. Among them were King Tigers that terrified American infantrymen who had never seen such massive vehicles. But within 48 hours, the mechanical problems predicted by German maintenance crews began to manifest. King Tigers broke down on narrow forest roads, blocking the advance of lighter vehicles behind them. They threw tracks attempting to maneuver on icy inclines. Their transmissions failed under the stress of continuous operation without proper maintenance intervals. Near the Belgian town of Stavelot, elements of the 1st SS Panzer Division were forced to abandon at least 3 King Tigers, not because they were destroyed in combat, but because they could not be moved. One had suffered catastrophic engine failure. Another had thrown both tracks attempting to climb a steep embankment. The third, the tank that Technical Sergeant James Bates would later examine, had experienced complete transmission failure after traveling less than 20 miles from its assembly area. American forces advancing through the area in late December found these abandoned vehicles. Standard procedure was to destroy captured equipment to prevent its reuse, but intelligence officers recognized an opportunity. Here were intact King Tigers that could be examined, measured, and tested. Orders went out: preserve these vehicles for technical analysis. Bates and his crew from the 3rd Armored Division received those orders on December 22, 1944. They were to secure one of the abandoned King Tigers, perform basic mechanical assessment, and prepare it for transport to rear area technical intelligence facilities. When Bates first saw the King Tiger, his reaction was visceral awe, mixed with professional dread. The tank was enormous, nearly 12 feet tall, over 30 feet long, including the gun barrel, and so wide it could barely fit on Belgian roads. The frontal armor sloped elegantly, and the long 88mm gun barrel suggested lethal reach. This was the tank that had killed so many of his friends. But as he walked around the vehicle, professional assessment replaced emotional reaction. The tank sat awkwardly, its right rear track sagging. The engine compartment hatches were open, always a sign of mechanical problems. The ground around the tank showed deep gouges where the crew had attempted to maneuver it, suggesting the breakdown had occurred suddenly, rather than gradually. Bates climbed onto the hull and looked inside the open turret hatch. The interior was cramped despite the tank's external size. Most of that 70-ton weight was armor, not internal space. The commander's position had a complex array of optics and vision devices. The gunner's station included sophisticated range-finding equipment. The loader's position was surrounded by ammunition storage, but what struck Bates most was the smell. Every experienced tanker knew tank interiors had a distinctive odor: oil, cordite, sweat, and fear. But this King Tiger smelled primarily of burned metal and transmission fluid. The mechanical compartment showed signs of extreme stress. Metal shavings in the transmission housing, evidence of overheating on gear assemblies, and worn components that should have been replaced long before they failed. American maintenance crews attempted to assess the damage. The diagnosis was straightforward. The Maybach transmission had experienced catastrophic failure of its primary gear assembly. The 70-ton weight of the tank, combined with the stress of combat maneuvers and inadequate maintenance, had exceeded the transmission's design limits. Repairing it would require replacement parts that the Germans themselves could not manufacture quickly enough to meet demand. The Americans tried to start the King Tiger's engine using portable starting equipment. The Maybach engine turned over but would not sustain operation. Fuel delivery problems compounded the transmission issues. After several hours of work, the maintenance crews concluded the tank could not be driven even short distances without major repairs. This presented a logistical problem. The King Tiger weighed 70 tons. American tank transporters were designed to carry 30-ton Shermans. Moving this captured vehicle would require specialized heavy equipment that was in short supply and urgently needed for other purposes. The solution was improvised and telling. American engineers used two M25 tank transporters working in tandem, reinforced the trailer beds with additional steel beams, and spent 3 days carefully loading the immobile King Tiger. The operation required a crane typically used for bridge construction. German designers had created a tank so heavy that even its captors struggled to transport it. While this was happening, technical intelligence officers conducted detailed examinations. They measured armor thickness at multiple points, confirming that frontal protection ranged from 150 to 180 millimeters, far thicker than any American tank. They examined the 88mm gun, noting its sophisticated breech mechanism and high-quality optics. They documented the internal layout, the crew positions, the ammunition storage. But they also documented the mechanical shortcomings, the transmission that had failed after minimal use, the engine that was underpowered for the vehicle's weight, the suspension system that showed signs of extreme stress, the tracks that were too narrow for the tank's weight, causing excessive ground pressure that contributed to mobility problems. One intelligence officer's report, now preserved in the National Archives, summarized the findings with professional understatement. While this vehicle represents advanced engineering in armor protection and firepower, its mechanical reliability is severely compromised by excessive weight and inadequate powertrain components. In its current condition, it represents a greater liability than asset to German forces. That assessment was more devastating than any after-action combat report. The King Tiger was not invincible. It was not even particularly reliable. It was a magnificent failure, a triumph of engineering ambition over industrial reality. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The captured King Tiger was eventually transported to the Aberdeen Proving Ground in Maryland, where American engineers conducted exhaustive testing. They fired captured German 88mm rounds at its armor to determine penetration resistance. They examined the metallurgy of the armor plates. They attempted to operate the tank under controlled conditions to assess its mechanical performance. The results confirmed what combat experience had suggested. The King Tiger could be penetrated by American tank destroyers armed with 90mm guns at ranges under 1,000 yards. The sloped frontal armor was effective, but the side and rear armor was vulnerable to standard American anti-tank weapons. Most significantly, the mechanical systems were so unreliable that sustained operations were impossible without extensive maintenance support. American tankers who examined the captured vehicle at Aberdeen had mixed reactions. Some were relieved to discover that the legendary King Tiger had such serious weaknesses. Others were disturbed by the implications if German engineering, which had dominated European tank design for years, was producing unreliable vehicles. What did that suggest about the desperation driving German war production? The answer lay in the broader context of German industrial capacity in late 1944. The Third Reich was running out of everything: raw materials, skilled labor, manufacturing capacity, and most critically, time. German tank production in 1944 totaled approximately 19,000 vehicles of all types. American tank production in the same year exceeded 47,000 vehicles, and American tanks, while less sophisticated individually, were far more reliable mechanically. The philosophy behind German and American tank design reflected fundamentally different approaches to industrial warfare. German designers pursued technological excellence, individual vehicles that were superior in armor, firepower, and theoretical capability. American designers pursued mechanical reliability and mass production vehicles that were adequate in combat performance, but could be manufactured in overwhelming numbers and maintained in the field with minimal specialized equipment. This difference became starkest when examining maintenance requirements. A Sherman tank required approximately 10 man-hours of maintenance per week of operation under normal combat conditions. The engine could be removed and replaced by a trained crew in under 6 hours using standard tools. Transmission problems, while still serious, could often be repaired in field conditions. Most importantly, replacement parts were abundant. American logistics ensured that spare parts reached frontline units with reasonable consistency. The King Tiger required approximately 40 man-hours of maintenance per week of operation. Removing the engine required specialized lifting equipment and typically took more than 20 hours. The transmission, when it failed, almost always required complete replacement rather than repair a task that was nearly impossible in field conditions. And by late 1944, replacement parts for King Tigers were scarce even in German rear area depots. American intelligence officers studying the captured King Tiger recognized something that German propaganda had obscured. Advanced technology was meaningless without the industrial capacity to support it. A 70-ton tank that broke down after 20 miles of travel was not superior to a 30-ton tank that could travel 200 miles without major maintenance. Sophistication without reliability was a liability, not an asset. This realization spread through American armored forces during the winter of 1944 and 45. Tank crews who had feared German heavy tanks began to understand their vulnerabilities. Briefings emphasized that King Tigers were slow, mechanically unreliable, and vulnerable to flanking attacks. Intelligence reports noted that abandoned German heavy tanks were becoming increasingly common, not because American firepower was improving, but because German maintenance capabilities were collapsing. The psychological impact on American tankers was significant. The King Tiger had represented technological dominance, the idea that German engineering could compensate for numerical inferiority. Discovering that these massive tanks were mechanically fragile undermined that mythology. American crews gained confidence not from improved equipment, but from improved understanding of their opponent's limitations. Meanwhile, German tankers were living the reality that American intelligence was only beginning to document. Hans von Loch, a commander in the 21st Panzer Division, later wrote in his memoir that mechanical reliability had become a more pressing concern than enemy action. His unit had received several King Tigers as replacements in January of 1945. Within 2 weeks, only one remained operational. The others had suffered mechanical failures that could not be repaired with available parts and equipment. German maintenance crews performed near miracles keeping heavy tanks operational. They cannibalized disabled vehicles for parts. They improvised repairs using whatever materials were available. They worked through Allied air attacks and artillery bombardment to keep their tanks mobile. But there were limits to what improvisation could achieve. A transmission designed for 50 tons of vehicle weight could not be coaxed into reliably moving 70 tons, regardless of maintenance crew skill. The captured King Tiger that Technical Sergeant Bates had examined was eventually joined at Aberdeen Proving Ground by 2 additional vehicles captured in different circumstances. One had been abandoned near Houffalize, Belgium, after suffering engine failure. Another had been captured nearly intact, near the German border, Its crew had fled when American infantry surrounded their immobilized tank after a track failure. American engineers conducted comparative tests between these King Tigers and captured Tiger I tanks, as well as American and British heavy tanks. The tests revealed a consistent pattern. German tanks prioritized firepower and protection over mobility and reliability. Allied tanks, particularly American designs, prioritized mobility and reliability over individual combat power. Neither approach was inherently superior, but the strategic situations of late 1944 favored the Allied philosophy. Germany was fighting a defensive war with shrinking territory, collapsing logistics, and diminishing industrial capacity. In those circumstances, mechanical reliability mattered more than theoretical combat superiority. A tank that could not reach the battlefield was tactically worthless, regardless of how powerful its gun or thick its armor. The metallurgical analysis of King Tiger armor plates revealed another troubling reality for German forces. The steel quality was inconsistent. Some plates showed excellent properties while others were brittle and prone to cracking. This variation reflected the deterioration of German steel production as the Allied bombing campaign destroyed industrial facilities and cut off supplies of critical alloying elements like manganese and chromium. American metallurgists testing captured armor plates in early 1945 discovered that some King Tiger frontal armor could be penetrated by standard American 76mm guns at ranges under 800 yards, not because the armor was thin, but because poor steel quality made it susceptible to cracking rather than deflecting projectiles. This was not a design flaw but a manufacturing quality problem driven by Germany's collapsing industrial infrastructure. The strategic implications were profound. German tank designers had created vehicles that required industrial capacity Germany no longer possessed, not just for manufacturing, but for maintaining steel quality, producing replacement parts, and supporting field operations. The King Tiger represented the gap between German military ambitions and industrial reality. By February of 1945, American intelligence estimated that fewer than 30% of German King Tigers were operational at any given time, not because they were being destroyed in combat, but because they were broken down awaiting parts and repairs that would never come. Some German heavy tank battalions reported that they spent more time towing disabled tanks than engaging the enemy. The human cost of this mechanical unreliability was considerable for German forces. Tank crews who had trained extensively on these sophisticated vehicles found themselves fighting in less capable tanks or being transferred to infantry units. Maintenance crews worked themselves to exhaustion, attempting impossible repairs. Commanders planned operations around the assumption that only a fraction of their authorized strength would actually be available. One German tank commander, interviewed after the war by American historians, described the psychological impact of mechanical unreliability with bitter precision. He had commanded King Tigers during the Ardennes offensive and had watched his battalion's strength dwindle, not through combat losses but through mechanical attrition. "We feared breakdowns more than enemy fire," he recalled. A tank destroyed in combat was at least doing its job. A tank broken down on the roadside was just an obstacle and a source of shame. That sense of shame reflected a deeper crisis in German military culture. The Wehrmacht had prided itself on technological sophistication and tactical excellence. Discovering that their most advanced weapons were mechanically unreliable undermined confidence in German military-industrial competence. If the engineers and factories could not produce reliable tanks, what else had they failed to deliver? For American forces, the captured King Tigers provided tangible evidence of German industrial decline. Intelligence briefings in early 1945 explicitly noted that German equipment quality was deteriorating across all categories. Soldiers were encouraged to exploit German mechanical vulnerabilities rather than fixating on theoretical combat capabilities. This shift in understanding affected tactical doctrine. American tank units developed procedures specifically for dealing with disabled German heavy tanks. Reconnaissance elements would identify immobile vehicles, artillery would destroy them if they posed a threat to American movements, and infantry would secure them to prevent German recovery efforts. The focus shifted from defeating King Tigers in combat to preventing their employment by accelerating their mechanical attrition. The psychological warfare implications were also significant. American propaganda leaflets dropped over German lines in early 1945 included references to the mechanical unreliability of German heavy tanks. The message was clear. German industry could not support its military, and German soldiers were being asked to fight with equipment that would fail them at critical moments. Those leaflets were accurate. German tank production records from early 1945 show that manufacturing quality continued to deteriorate as Allied bombing disrupted supply chains and destroyed specialized factories. New King Tigers rolling off assembly lines often had known defects that manufacturers lacked the resources to correct. Some tanks were delivered to combat units with temporary repairs that would not survive sustained operations. The final operational King Tigers saw combat during the defense of Germany in March and April of 1945. By this point, mechanical reliability had become so poor that German commanders often positioned King Tigers as static defensive positions rather than mobile combat vehicles. They were essentially being used as fortified pillboxes, a role that required none of the sophisticated engineering that had made them so expensive and difficult to produce. American forces, advancing into Germany in the war's final weeks, encountered numerous abandoned King Tigers. Some had been deliberately destroyed by their crews. Others had simply been left behind when they broke down and could not be repaired or recovered. A few were captured intact when their crews surrendered rather than attempting to escape in disabled vehicles. Technical Sergeant James Bates, who had examined that first captured King Tiger in Belgium, encountered another abandoned specimen near Paderborn in early April 1945. This one had suffered a thrown track, a relatively minor mechanical problem that would have taken a few hours to repair under normal circumstances. But by April of 1945, German forces lacked the recovery vehicles, spare parts, and time to perform such repairs. The tank had been abandoned, its crew presumably absorbed into infantry units or simply walking home. Bates later recalled his reaction to finding that second abandoned King Tiger. The first one, captured in December, had impressed him with its size and sophistication despite its mechanical failures. This one, encountered 4 months later, struck him primarily as pathetic, a massively expensive weapon system abandoned because of a routine mechanical problem that any competent maintenance crew should have been able to fix. That emotional shift from intimidation to pity reflected the broader transformation in how American forces viewed German military power. The mythology of German technological invincibility had been replaced by an understanding of German industrial exhaustion. The King Tiger symbolized that transition from fearsome weapon to maintenance burden to abandoned relic, all within the space of a single year. The captured King Tigers that American forces transported to Aberdeen Proving Ground remained there for decades as museum pieces and technical references. Engineers and historians continued to study them, drawing lessons about tank design, philosophy, industrial capacity, and the relationship between technological sophistication and operational reliability. One of the most significant lessons concerned the danger of pursuing technological excellence without adequate industrial support. German designers had created a tank that exceeded their nation's ability to produce, maintain, and support. American designers had created tanks that were adequate rather than exceptional, but that adequacy was sustainable across tens of thousands of vehicles. The production numbers tell the story with brutal clarity. Germany manufactured approximately 490 King Tigers between January 1944 and March 1945. During the same period, the United States manufactured over 21,000 Sherman tanks and tank destroyers. Even accounting for the King Tiger's superior individual combat power, the numerical disparity was overwhelming. But more significant than production numbers was operational availability. American armored divisions could typically field 75 to 85% of their authorized tank strength on any given day. German heavy tank battalions, even when fully equipped with King Tigers, rarely fielded more than 40 to 50% of their strength due to mechanical problems. Numerical superiority combined with mechanical reliability created an insurmountable advantage. Post-war interviews with German tank designers revealed that many had recognized these problems during development but had been overruled by military leaders who demanded maximum combat capability regardless of practical constraints. One engineer involved in King Tiger development told American interrogators that he had recommended limiting the tank's weight to 60 tons to reduce stress on the powertrain. He was told that combat power took precedence over mechanical concerns, a decision that haunted German armored forces throughout 1944 and 45. The King Tiger represented a broader pattern in late-war German weapons development, increasingly sophisticated systems that Germany lacked the industrial capacity to produce in meaningful numbers or support in field operations. Jet fighters that required exotic materials and skilled labor Germany could not provide. Submarines with advanced technology but crippling mechanical complexity. Guided missiles that worked in testing but failed in combat conditions. This pattern reflected desperation rather than incompetence. German engineers understood the limitations they faced, but the strategic situation of the Third Reich in 1944 offered no good options, only choices between different types of failure. Pursuing technological superiority was at least a choice that maintained some hope of reversing Germany's deteriorating military situation. Accepting technological parity while being overwhelmed numerically was simply accepting defeat. The psychological impact of this approach on German soldiers was corrosive. They were told they possessed superior weapons but experienced constant mechanical failures. They were assured that German engineering excellence would compensate for Allied numerical superiority, but watched disabled tanks being abandoned for lack of spare parts. The gap between propaganda and experience bred cynicism that undermined military discipline and morale. American soldiers, by contrast, developed confidence in their equipment precisely because it was reliable rather than exceptional. Sherman tanks were not individually superior to King Tigers, but Sherman crews knew their vehicles would start when needed, reach the battlefield when required, and continue operating through sustained campaigns. That reliability bred confidence that no amount of propaganda could replicate. The captured King Tigers also influenced American tank design in the immediate post-war period. Engineers studying the vehicles noted that extremely heavy armor and powerful guns were useful for specific tactical situations, but created excessive mechanical complexity for general-purpose vehicles. The M26 Pershing heavy tank, which entered service in the war's final months, represented a middle ground better protected and armed than the Sherman, but far more reliable than German heavy tanks. But the broader lesson concerned industrial strategy rather than specific design choices. American military planners concluded that sustainable production of adequate equipment was preferable to limited production of exceptional equipment. This philosophy would shape American military procurement for decades, sometimes to beneficial effect, other times leading to its own problems when adequacy proved insufficient for changing battlefield conditions. The men who had captured and examined those King Tigers in 1944 and 45 carried their own lessons forward. Technical Sergeant James Bates returned to civilian life after the war and worked as a mechanical engineer for a major automotive manufacturer. He occasionally spoke about his wartime experiences, and when he did, he emphasized the captured King Tigers as examples of engineering disconnected from practical reality. They built a tank that couldn't do the job it was designed for, he told an interviewer in 1973. Not because the designers were incompetent, but because the job they were asked to do was impossible given Germany's situation. You can't engineer your way out of industrial collapse and strategic encirclement. That King Tiger we found in Belgium, it was magnificent and useless at the same time. That assessment captured the essential irony of the King Tiger's story. Here was a tank that represented the pinnacle of armored vehicle design in 1944. Sloped armor that could defeat any Allied tank gun, a main gun that could destroy any Allied tank at extreme range, sophisticated optics and fire control systems that gave it technological superiority in every measurable category. And it broke down after traveling less than the distance from one Belgian village to the next. The abandoned King Tigers that American forces captured and examined revealed a truth that German propaganda had worked desperately to conceal. Technological sophistication was meaningless without the industrial capacity to support it. Advanced engineering could not compensate for inadequate manufacturing quality, insufficient spare parts production, or collapsed logistics networks. The most powerful tank in the world was just an expensive roadblock when its transmission failed and no replacement parts were available. For the German tankers who had trained to operate these vehicles, who had been told they represented German technological superiority, who had believed they would turn the tide of battle. The reality was devastating. They watched their sophisticated tanks break down, get abandoned, and fall into enemy hands, not because they were defeated in combat, but because they simply stopped working. For American tankers who had feared these vehicles, who had known comrades killed by their powerful guns, who had developed tactics specifically to avoid engaging them directly, the discovery of their mechanical fragility was revelatory. The King Tiger's greatest vulnerability was not thin side armor or limited gun depression. It was the transmission that would fail after minimal use, the engine that was inadequate for the vehicle's weight, the tracks that would throw themselves under stress. The captured King Tigers that ended up at Aberdeen Proving Ground bore silent witness to this fundamental truth about industrial warfare. Wars are not won by the side with the best individual weapons, but by the side with adequate weapons they can produce, maintain, and support in sufficient numbers. German engineering had created a masterpiece. German industry could not sustain it. That gap between engineering ambition and industrial reality was unbridgeable by late 1944. Those massive, abandoned tanks scattered across Belgium and Germany in the war's final months told a story more devastating than any after-action combat report. They were monuments to misdirected priorities, to desperation masquerading as confidence, to the fatal belief that technological excellence could substitute for industrial capacity. They were, in their own way, more effective propaganda for Allied superiority than anything American psychological warfare units could have created. The King Tiger that Technical Sergeant Bates examined in December of 1944 still exists, preserved at the United States Army Ordnance Museum. Visitors can walk around it, marvel at its size, examine its thick armor and long gun barrel. What they cannot see from outside is the failed transmission, the worn engine components, the mechanical complexity that made it simultaneously impressive and impractical. That hidden mechanical reality, invisible to casual observers but obvious to anyone who examined the vehicle's internal systems, was the true story of the King Tiger. It looked invincible. It was supposed to be invincible. German propaganda insisted it was invincible. And it broke down before reaching the front line, captured intact by soldiers who had been taught to fear it, revealing itself to be less a weapon of war than a symbol of the gap between German ambitions and German capabilities in the war's final year. The irony was lost on no one who examined those captured vehicles. The tank designed to restore German armor superiority through technological dominance became evidence of German industrial collapse. The weapon meant to terrify Allied soldiers became an object of fascination and, eventually, pity. The engineering triumph became a maintenance nightmare that German forces could neither fix nor abandon quickly enough. 3 miles. That was how far that particular King Tiger travelled before its transmission gave out. 3 miles from its assembly area to its final resting place as a captured exhibit. 3 miles that summarized the entire story of German late-war weapons development. Ambitious in conception, sophisticated in execution, fundamentally unsustainable in practice. Technical Sergeant James Bates stood beside that immobilized 70-ton tank in December of 1944, and he understood what he was looking at, not just a disabled enemy vehicle, but evidence that the war was already decided, not by battles won or territory captured, but by industrial capacity and mechanical reliability. The side that could keep its tanks running would defeat the side with superior individual tanks that could not be kept operational. It was an unglamorous truth, far less dramatic than stories of tank versus tank combat or heroic last stands. But it was truth nonetheless, validated by every abandoned King Tiger that American forces encountered in the war's final months. The most powerful tank in the world, defeated not by superior Allied weapons, but by its own mechanical complexity and Germany's inability to support it. That was the real story of the King Tiger, not invincibility, but unsustainability. Not German engineering excellence, but German industrial exhaustion. Not a wonder weapon that could change the war's outcome, but a sophisticated machine that broke down before it could make any difference at all. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.